Hello class. I hope everybody is fine and you are listening attentively. Now we are on our second topic of Senior 2 and I hope you recall the first topic was functions and was relations and mappings together with functions. I hope you recall that. And today we are talking about another new topic here, but we request for your maximum attention. Now let me pause this. You see, we love tricky questions to polish our minds. Are you ready to listen to that tricky question and you answer before we start? Now the tricky question is this. There are two goats in a place. Listen very, very well. There are two goats which are in front of other two goats. Two goats are in front of two goats. And then, in the same area, at the same place, two goats are on one side of other two goats. How many goats are in the place? Let me repeat. Two goats are behind two goats are in front of two goats, and two goats are on one side of two goats. How many goats are there in the place? Yes, I can see Grace.
I think there are 6 goats.
There are 6 goats. You reason out that. Who else has an observation? 6 goats. 6. Are you also 6? 6 goats. Also 6? Let me repeat the question. In an area, 2 goats are in front of 2 goats. Then 2 goats are on one side of 2 goats. How many goats are in that area? 2 goats are in front of 2 goats. 2 goats are on one side of 2 goats. How many goats? You want to try again?
Yes. There are 2 goats.
There are 2 goats. Another try?
I think there are 4.
Why are 4 goats correct? 4 goats is correct. Why? Just explain, Mukisa. No, we give chance to patience.
Yes, teacher, according to my illustration here that I do in my book, that 2 goats are in front of 2 goats, and 2 goats are one side of 2 goats. So one side of the 2 goats is, I think, behind, and there are 4.
There are 4 goats. Rather, it is a square, not so?
Yeah.
A square of 4 goats. Yeah, thank you. Now, that's very, very good. Now, our topic today is topic 2, and that is what? Topic 2 is vectors and translation. Vectors and translation. That means we shall divide our lesson into two major subtopics. That's vectors alone, and under vectors we shall look at various parts. Meaning of a vector, then we shall see representation of a vector, Then we shall also see types of vectors or categories of vectors, and we shall also visit magnitude of a vector, but we shall see operations on vectors also. That's addition, subtraction. That's addition, subtraction, and addition and subtraction. No division, neither multiplication. And we shall also see now translation, and we shall look at how do we definition of a translation, then we shall see representation, then we shall see some determining the new from the figure, that's determining the image, after translation. And that will really be the end. It's not very, very long, and I request that we pay maximum attention, and hoping that you have a graph book, and you have a pencil, a ruler, and in general a set. Yeah, we can pick on we start on a vector. We start on a vector. I hope you are paying attention. You're paying attention. Vectors is our first subtopic here. Vectors, that means capture that. Vectors. Yeah, now we are going to see what does that word vector mean. We can just refer ourselves to two situations here. If we asked you to walk and you go to a toilet, you know that? Which direction is the toilet? Which direction is the toilet?
It's in the west.
From this place, what would it be? It would be northeast. Which distance do we think it is?
Like around.
Estimate the distance from here to the place.
20 meters. It's the west.
20 meters. About 20 meters. That means it has 20 of my width here.
Yes.
About 20 meters. Now when we consider direction and we are able to locate how long it is, the how long is what we are calling the length, and sometimes we shall call it magnitude. From here to the toilet is about how long? How far rather? 20 meters, not so? Now the 20 meters from here to the toilet is what we are calling the length, and the what? The direction being put into consideration. When we put direction into consideration and we are locating a point, then what we are talking about is what we call a vector. Now that vector from here to here, from here to the toilet, it would just be now called displacement. We are locating position from here to the toilet, and we are taking direction into consideration. Now, in case we only emphasized on the distance without putting direction into consideration, then we would not be talking about what? A vector. See? That means we would be talking about something called an ordinary number called a scalar. That means 50 meters in the direction of northwest is what we are calling a vector. Is that right? But 50 meters without direction is just distance, and it's called a scalar. Whereas 50 meters northwest is called displacement. Do you see now the two words differing? Displacement is now the length with direction inclusive, but distance is the length from one point to another without direction. Now let me ask you, assuming I'm running a car is being drove at 20 kilometers per hour in the direction of west. Clear?
Yes.
I hope you are taking that into consideration very, very much. A car is drove at 20 kilometers per hour due west, that means going west, and also another car is being drove at 20 kilometers anyhow, without direction considered. Which one is a vector? Yes? Yeah? Yes.
The one that has the direction of
the one that has direction of the waist. But now you see that speed, now one is called the speed and one is called the velocity. Which one will be called the speed? Yes, Mukisa?
The one without direction.
The one without direction. Then the one with direction is called velocity. Therefore, in short, give me some examples of vectors. Already from our discussion, there are answers. Patience.
Weight.
Weight is a vector. Could you must be able to tell us why weight is a vector?
Weight, first of all, weight is the measure of how gravity works on an object.
How gravity works on the object.
And gravity pulls objects towards the earth.
In the direction of towards the earth.
Yeah. So there is direction. There is not only size, but also direction is involved. So weight is
not only size, but direction is also considered downwards. See? That's right. Now, I think that's true. Could you think of if a question came, a person, I walk in front 5 steps, then I return 3 steps. What would be my distance and what would be my displacement? What would be my length in vectors and what would be my length in scalars? Now I'm walking 5 steps up front, 3 steps behind. Not so? Therefore, which one would total be 7 and which one would be 3? And could you explain that? I walk 5 steps up front and reverse 2 steps backwards. Which one would you consider answer to be 3, a vector or a scalar? And which one would give the answer 7? 5 steps forward, 2 steps backward. There are 2 answers. The answer is the total distance moved by means 7, then there is an answer of a 3. Which one would be, could you explain the 2? I want different hands also. And different hands. Okay, let us still have because of time. No? Mukisa, yes. You think?
I think the 7 can be the vector.
7 is the expressing vector. Then why?
Because both the 5 steps move forward and those 2 steps move backward have both directions.
What is the difference between going forward, assuming you go 5 steps forward and 2 steps more forward? Let me see Ruth first, before Mukisa can complete our statements. Yes, Ruth. Are you different from Mukisa?
But then teacher, as you said, that if someone moves 5 steps,
forward,
2 steps
backward. Okay. You have a suggestion? Yes, Patience, your opinion?
7 is scalar.
Why?
Because it is minding about size, not direction. If I was
Say that statement again.
I think it is scalar because it's focusing on only size.
Love for her. 3 is a vector because that's very wonderful. See, now why? Because you see, when you move 5 steps, we are taking that to be positive direction. Then you are reversing. That means you are dealing with direction. You are putting it into consideration. Therefore, when you move forward 5, 2 backward, and that means it will be 5 plus negative 2. That will be catering for direction, and that will be a vector. So 3 would be representing displacement, a vector, and 7 is distance, a scalar. So let us define a vector. Now get us the definition. What's a vector? Yes, what's a vector and what's a scalar from our discussion? Still Patience? No, I'm denying her the chance. Patience, speak for us whom you would want to answer that question.
My name on the left.
On the left. On the left is which name is on the left? Millie.
Try.
Yes, Millie.
A scalar. I'm defining a scalar. A scalar is the displacement of objects.
A scalar is the displacement of objects. Good trial. You seem not to be confident of your answer. Why? Why are you doubting it? Is it wrong?
I don't.
You don't know. Okay, wonderful. Chance to Mukisa.
Okay, so I'm defining a vector.
Yes, what's a vector?
A vector is a displacement of an object in consideration of the direction.
But remember that in our discussion we talked about displacement and velocity and distance and speed. So are you correct? Okay. Thank you.
Teacher, let me try my luck.
You say she's wrong?
No, I'm just trying.
Okay, try your luck and we see if you agree with her.
Actually, I agree with her, but I'm just trying my own definition.
Yes, do so.
A vector is the displacement of an object according to the direction and velocity at which the object is being displaced.
Thank you. Now, let me add here another scenario here because somebody has defined the vector in terms of examples, not so? Assuming I'm changing my speed at a rate of I'm changing my speed after every 4 seconds in a certain direction. Did you hear that? I'm changing my speed after every 4 seconds in a certain. But again, there is a scenario where I'm changing, I'm trying, this time I run for 20, another time I change it to 40, but I'm not considering direction. Now the changing of speed is what I'm calling again acceleration. Did you hear that? That means, again, another example of another vector is acceleration. So, we can say a vector is a physical quantity or a number. Maybe you are used to a number. Because you didn't want to say those words, but they remain the same and correct, that's all. That's why you are fearing to say, okay, is a physical quantity, or open bracket, a number. Which is expressed using both magnitude and direction. I think that's flat enough to be understood, not so? So, examples include what? Acceleration, velocity. Velocity is just speed in a certain direction. So, weight. There are very, very many. Are you adding more? Force, yes. Pressure. That means I will request you to again download more from Google. A scalar is a physical quantity expressed in terms of only what? Magnitude. Now the word magnitude, we said it also just means the length or size. Size like 20 kilometers flat. Yeah. Yeah, now representation of examples of scalars, have you given them to us?
Mass.
That is mass. Speed. Area. Yes. I think those are correct. Density, distance, Okay. Now, representation of a vector. So we know that a vector must have both magnitude and, you see that? Now, you can capture that. Now we have two or three representations here, depending on the situation. Listen that very attentively. Like, if you just wanted to represent the length, you can either just draw an arrow in the amount that the length is. In the amount that the length is, we mean what? We mean if the length is 6 kilometers in the west direction, then you have to measure 6 centimeters on your ruler and draw 6 centimeters. If there are big values like miles, 5,000 miles due north, then you'll have to create a scale if you are drawing for us on a paper. You see that? See that? Now, that we can have geometrical representation. And this is done using a line with an arrow. A line of a certain length with an arrow. Yeah. An arrow. This is done using a line of a certain length with an arrow. That have moved from point A to point B. And now you see what you have drawn here, from here to here must be measured. See, if we say vector AB is 6 kilometers due west, and the vector CD is 4 kilometers due the same direction west, then we would expect you to draw different lengths. You must draw 6. And I've told you that use an appropriate scale on the paper in case you wanted to use it drawn in the book. That means you can let maybe every 1 centimeter be 1 kilometer, so that 6 centimeters can be 6 kilometers can be. Then you can say let 1 centimeter be equivalent to 1 kilometer, so that now 6 centimeters will be 6 kilometers. So that's geometry of vectors. You capture that? Now we can have symbolic representation of a vector. Symbolic representation. Now, in symbols, we just symbolic means we use, this is done using letters containing either, now there you are. We can use the letters containing a right arrow on top, using letters containing a right arrow, comma. How do you call this in English? Approximate is 2 of them. You will check on internet. It's called what? That symbol is called accent. But since we put it below, we call it under accent. That letters containing right arrow on top or an under accent yes, or bolded letters. You see? Yeah. Now, e.g., you can find vectors that from A to B is represented by what? That term from A to. See? Therefore, when you put the arrow this way, you'll mean from B to. See? Now, or we can use an under. The word ascent means up and down movement. That's why they call it that. That's your English. Now listen. Most textbooks, I think due to ease to write, they do not put these things, but just simply write as bold. They will write vector A. When you see bold, I hope you understand bold in computer, to make it more thick. The letter is made more thick. Missing of this, if you just write A, B, you don't score. Now, for you in the books, you must put either this or that with the right arrow or the under accent. But don't use bold, because nobody will understand, will think you have rubbed. So that. Now, listen. Now, since for us mathematics, you see, mathematically, most movements here, we represent them on a graph what? Graph paper in a plane called the Cartesian what? Plane. What's a Cartesian plane? You call it the coordinates. That's just x and y axes. That plane. That plane is called the Cartesian plane. Now in the Cartesian plane representation of the vectors, that's now Cartesian plane representation. There we use a column vector. They are represented as column. Now there you are. Column vector x, y. Now that means you'll find that x shows you are moving in x, the units in the x direction and the units in the y. How people are really capturing that. So, e.g., if we say negative 2, 4, this one we shall call it later, we shall study later, that is just an ordinary coordinate, x and y, but we just inverted it to be a column. So, it will show that you moved how many units. Let me just put roughly an estimate there. That I first moved how many units? Then you went up to here. That means my point is here. That means I can, the actual vector being required from the origin will be this line. That means to reach this point, instead of going direct, I've moved negative 2 and positive 1. See? That's the column vector. Yeah. Now, you see, math is really very, very simple. Did you know that?
Yes.
I knew it also. So, now you capture the types of vectors here now. Types of vectors here, or category. Yes, patience you're asking?
Teacher, when they give like A to B, then can the values of A, are they the ones that be above or the values of
Now,
or it depends on the direction?
now, I request that we look at types, and the question will be answered in the types. Yeah. Types of vectors. We have position vector. Then we have displacement vector. A column vector is a representation. Not so, that's why we can't put it here. Because both position and displacement will be expressed in column form. Yeah. So now you start with the position vector. Now position vector is just a vector used to locate a point from the origin. See? It is particularly from the origin. Did you pick that?
Yes.
So, for example, coordinate 2, 1 forms the position vector locating A. You know, when you plot A, let me just use an illustration, assuming we are plotting the coordinate, but this coordinate is going to represent a certain vector from the origin. See? Now, if you plotted that point, say if we plot where shall we plot? To above to here.
Yes.
Now, the vector we are talking about is from here to, you get that? The vector is now going to be called O2, which we can either use this or the adjacent. Now, we can't write it as a coordinate again because the coordinate is a single point, but a vector must be 2, 1. To mean I moved that to reach A is to move from O to 2, then 2 to what? Yeah. Now, for example, coordinate A forms the position vector OA. Have you captured that? Coordinate A, 2, 1 forms the position vector OA, which is 2, 1. I think that maybe somebody would want to be shown that diagrammatically. I hope people capture that. Now, that coordinate you've said it is here, not so. That is A, which is 2 what? And the vector we are talking about now, it's called O what? OA, which is this, O to A. You see, now I think you will notice that a coordinate is just expressed as a column to become a what? A vector. You see? Because when you have B to -4, its vector is OB to -4, not so? Showing that you can, to reach B is to move 2 units in the X positive and 4 units in the Y negative. Yeah. So that's very, very pretty clear. Have you represented that vector OA? Yes. Now That is OA. OA. Now, as long as you are from the origin to a point, you are talking about position. Yeah. You can give yourself. Okay, let me now ask the class here. Given the following coordinates, that's kind of an example. Given the following coordinates, P1, 1, 2, negative 4, 4, R, 2, 0, write the coordinates as position vectors. And maybe this can be personal assignment. Could you be able to put the vector that you have, the position vector, on a graph paper?
Yes.
So the line must be drawn at that point, not so?
Yes.
That means you have P becomes what? P becomes OP vector with 1, 1, etc, etc, etc. Let us discuss displacement. Now I request that as we discuss this, don't forget the other subtopic that was called ratios in vectors was left out. Capture that first. Ratios in vectors should not be left out. So now let me point you to this. I'm not talking about displacement vectors. You can have your illustrations, not so?
Yes.
Now I want you to look at this. I'm talking about, we want to define a displacement vector, but we must look at this, not so? Yeah. This is 1, 3, 4, and then this is 1, 2, 3, 4, 5, 6. Y-axis is -1, -2, -3, 2, -3, -4. X-axis. Are you in agreement of that? Now let me have a point here called the point what? A is 1, 1. Not so? Now I have another point 4, 4, 5. Called point B, 4, 5. Now, Miller, give us that ruler. The square one. Yes, the rectangle, the triangular one. Now, if I join the base, allow me to lift this for the interest of the lesson. I've lifted the A to go to 1, 3. You agree?
Yes.
Now, I join this and I create a vector called the A to what? Now, I've not located the AB from the origin, but I've located the AB from different points away from the origin. Now, a vector that is not in reference to the origin is called a displacement
Vector.
And that means a displacement vector is a vector representing the position of one point from another, but not from see. Now I want you to, this one you sketch it, make sure you sketch it in the notes as e.g. e.g. Now I want us to really get a formula for any displacement vector. Keep note there very, very well. e.g. AB, then you sketch that. Now, I want you to see this. No, you don't need to put in a graph paper. What will be in the graph paper will be asked for you to put in the graph paper. Now look here. If I wanted the answer for AB in terms of A and B, see, every vector must be referenced at the origin. Must be the answer for a displacement vector must be in terms of positioning vectors. Listen to that, let me say it again. The answer to a displacement vector must be in terms of position vectors. How? Now, if I'm to move from this point to that point, instead of taking this route, I must first go to the what? So, I'll move reversibly. Then I will also, that means I will have to move like this then. Now, there is a vector here that I have called what? OA, and there is a position vector called OB. Now, let me ask you. From my diagram there, what is OA? And what is OB? Yes?
OA is 1, 3.
1, 3.
Then OB is 4, 5.
4, 5. I think we agree that you just invert it to a conform. Now, look here. How can I reach B from A instead of taking direct route? I have to say A, but remember that I have O to A. When you reverse a vector, you reverse direct. So, if it's a positive direction, you change it to. So, AB vector will be A what? Plus OB. Are you in agreement with me? Now, look here, look here. You see, A to O is the reverse of O to. See? Do you agree that this is true? I don't know whether you agree. Why is this one the same? I hope you understand that the position vector on the diagram must be O2, but me, I'm moving in the reverse direction. So, A to O is the negative of O2, that you just change the sign. If it's a positive, it changes to negative. Whenever you reverse a vector, you reverse the direct, or rather reverse the sign. Now, I want you to notice there's something there. I'm giving you a formula for any position vector. Next time I will say find the PQ. Yeah. Now, could a mathematician think that this is OB minus OA? So, we subtract 4, 5 minus this. That's the answer for AB. Yeah? Some will use cram work that whenever I'm finding AB, it is the second letter minus OB minus O. If you are finding PQ, it is OQ minus OP. Ruth, are you really seeing this mathematics of vectors?
Yes.
You are really seeing it. Okay. Now what's the answer here? 4, 5 minus 1, 3. Therefore you get 3. Now I'm going to ask you a question. What are the coordinates of AB? 3, 2. Now when the question says what are the coordinates, you don't again write it as a column vector. It's now not a vector but a coordinate. Therefore the coordinates of AB is 3, 3, 2. See? Now I want to give you discussion questions to find the displacement what? Vectors. Yeah. Okay, can I give you practice questions here? Given the coordinates, P is for 0 and Q -3, -4. Find the coordinates of PQ. Can I attempt that? You want to give it a try? Okay, come and give it a try. Let's give it a try, then we move to operations on vectors.
Okay, finding the coordinates for PQ, we shall have PQ, which will give us, so you'll have to interchange P from the origin, so it's OP, but then it will be interchanged to PO plus OQ. So this will give us, since we have to interchange this one, so it will become a negative, and we shall have negative OP plus OQ. Oh, sorry. So here, since this is a negative, it can still be interchanged to be OQ. This one? No, this is the one marking up. So it will be OQ minus OP. So what are the coordinates for OQ?
4 and 2.
We have -3, -4. then OP
4 and 0.
4 and 0. So the solution for this, we have PQ will give us -3, -4, minus 4, 0. So -3 minus 4, we have -1. So it will be PQ is equal to -3 minus 4, we get -1, and then -4 minus 0 will remain with -4. So the coordinates for PQ are -4 and -1 and -4.
Thank you, sir. Yeah. Now, just maybe, thank you very much. That's wonderful. Don't even show this, not so, since we've already come up with the formula. Just second minus first, not so. Second minus first. Yeah. I hope there is flat.
Yep.
Okay, I want now to drop to operations on vectors. It means vectors can be added or subtracted. Now, look here. Look here. When we are, I want you to really watch this. When I'm representing, if I have coordinate 2, 1, I want you to really look here. Here. If I have coordinate 2, 1, which will be here, not so? A. The vector is OA. Listen. The vector will be OA. Now, position vectors, we can use their smaller letters A or A to be called A, or B will be called B, or P is called smaller p. Now that position vectors of capital letters can be just simply written as smaller letters with an undercent, not again a. Now keep note that when you are using the undercent, it can work for capital letters as well as smaller letters, but for smaller letters you don't use the arrow. So, have you captured that? When we are representing, instead of saying oh, I can use a? Yes. Not so? Now, we are working on now addition and subtraction of vectors. Now, we can just take a general case here that just generally let A be x1, y what, and let OB be x2, y. And now don't forget, because you'll forget, like I've forgotten and put a fraction, not so? They are not fractions. Now we have said this can be called smaller a with an undercent smaller b. If we say find the OA plus OB, or rather more meaningful to use smaller a plus smaller b, that would be adding this to, you need to watch this. How do you add vectors? Was a clue? How do you add vectors was a clue? Yes, Ruth, you are trying. Ruth, try.
Stressing, we add the upper ones and also the lower ones.
That means we add the upper ones alone and also add downer ones alone. That is the sum of vectors. What if we have a case of small a minus b? How do we handle that? We subtract correspondingly. That's x1 minus x2, y1 minus y2. That's good. That's good. Addition and subtraction. You can illustrate that. Are we moving on smoothly and everybody is speaking everything? See that? You must. If you don't put, we think it's not a vector. But remember that in textbooks and other writings in exams, you'll find the letters just bolded as A. Did you hear that?
Yes.
That means when it's just bolded, you know it's a vector. That's exactly. Okay. Now that is how you add or subtract vectors. Now the next thing is multiplication of a vector by a scalar. We are still on operations of vectors. Now we want to multiply a vector. We are still under operations on vectors. That means small subheading them. Scalar by a scalar. Let small vector A be xy and k to a scalar. See that? That means now if we say Ka, if we multiply A by K, that K multiplies up and
Down.
so it will multiply X and multiply Y. That means I'll get Kx and Ky. Clear? Yes, that's very, very clear. Now I'm starting to put numbers here for people to assist the teacher, not so?
Yes.
Examples. Given vector P is 4, vector choice to 3, and vector R is 9, negative 2. Find part A. To P plus Q. Part B. R minus P. Who can guide us through? Yes, Mokisa, I want to take her through, but you have to use 1 minute because of time. Keep time.
Okay, finding 2p plus q, we have
You can use this part.
we have 2p plus q.
You can't reach up.
I can.
Please do so. Reach up.
Okay. 2p plus q. So 2p simply means you're going to multiply 2 with everything in p. So it will be plus q, which is 2, 3. So this will give us 2 times 8 times 4, 8. So 8 plus 2, 3. Sorry. So it will be 8 plus 2, then 8 plus 3.
Yeah, thank you, Grace Mokisa. Is it Ruth?
Yes. So the first has to find r
minus p.
minus p. So r is like 9 negative 2, and then p is 4. Oh, sorry. 4. So the last is to find r minus p, which is 9 negative 2 minus 4 and 4. So we have, as she said, we have to subtract the upper one separately and the downer one separately. So 9 minus 4, and then negative 2 minus 4, which is 5, and then, yeah, it is minus, it is negative 6.
Yeah, thank you very much. I think that's pretty easy. Okay, let us try to check somebody lastly, and we go to magnitude. Now, I think that one can be paused if vectors A is equal to x4, B is negative 2, negative 2, and vector C, don't forget the underside, negative 1, negative 6. Find the value of x such that you are there, such that 2 vector A plus B is equal to C minus A minus B. Who can demonstrate that in 2 minutes only? And I try, then we got magnitude. Anybody willing? Take on that. Now, two vectors are equal if the corresponding elements are equal. See? That means 2a. That means that will be 2x4. Clear?
Yes.
Plus
Negative
2 equal to c, which is -1, -6 minus -2. That gives us here 2x. Clear? 8 plus -2, giving us negative that, minus -2, negative -2. That gives us 2x plus 2x minus 2. Clear?
Yes.
That is 8 minus then that will be roughly what?
Negative 4.
Negative 4. Now that one, -4. Wait, my number has an error.
No, here, that one you're adding 2a plus b, then go a.
Chapter there is a mistake. No? Here. It's supposed to be -1.
This one is
No, here.
-2.
Here the working, the second working is equal to -6. I thought it's supposed to be -1.
Negative?
1. Here the second step.
Yeah?
Yes.
No.
No? The next one down. Yes. It's supposed to be -1 minus -2.
-1 minus -2, not so? That's pretty good. Now, I would just want you to improve these denominator values. Clear? That is 4 here, and that's -2. That is 4 here, not so?
Yes.
What is the answer? 4 minus -2. I think you multiply the signs, not so?
6.
This gives us 6.
Yeah, but the upper one doesn't give us 4.
Are you sure?
Yes.
What is this?
-1 times 4.
No, this gives us
Gives us
1. That's good. This gives us
6.
6. We got 1 out of 6. Now, two vectors are equal if the corresponding elements are. Therefore, up must be equated to 2x minus 2 plus 2 equal to 1 plus 2. 2x is equal to 3 out of 3. Out of 2. That means x is 3 out of 2. That's good. That's good.
So what if maybe the equation has kind of a B section, yeah? Then
Yes.
they're asking maybe another question using that Gaussian vector. And you have got a fraction.
You substitute it back there. It should remain in fraction form. It would be, A would now be a half with the 0.5, and it's because I've not been putting fractions for you. Maybe I will start putting them. She's asking that in the case A would be now a half for or 0.5. Clear? Yeah. Now let us go to magnitude of a vector. Magnitude of a vector. Okay, magnitude is also called the size or length or modulus. Hope you capture those terms. They can say find the modulus, find the magnitude, find the size, find the length. Okay. Now I want us to see magnitude from this. Are we in maximum attention? Now look here. Consider vector A, which is 2 what? Let me use 3, 4. Now, if we sketch that, of course, smaller a also means OA. Did you hear that?
Yes.
Okay. Now you guide me how to plot and where to plot. Yes, could you guide me where to plot? This one sketch them in the normal notes, not so? Yes, do dot sketch on the graph papers. Okay. I plot 3, 4.
Positive A, but on the same line with positive.
Say it again.
Above positive A.
You should be a teacher.
Hey, no.
These guys, why don't they want to be teachers? Teachers suffer very, very much. And they have suffered in the pandemic. But then who will teach others if me I get old? Patience, who will teach your children? Robots and guys, where are you heading? In the robotic world? That's great to hear. Now look here. This point is A. Clear? We can't say it is small a. No. Now we draw it from the origin. Now that is vector what? Vector A. Not so. Now how did we reach A? If I don't go directly, how will I reach A? I follow 3 units positive. Not so? 3 units positive. Then 2 units also positive. Do you agree?
Yes.
Oh. Now let me ask you. Sorry. This is, how many units are this in case I'm using measurements? 4 units. How many units are this one? 3 units. Now, the question goes to you. How do I find this length? I've seen hands. Do you hear from?
I think you use S squared equals to C squared equals to B squared plus C squared plus.
That means you are using, whose rule are you using?
Pythagoras theorem.
Great. That means magnitude of a vector will always be determined using Pythagoras theorem. Now, that means in general, before we complete on that diagram, in general, how do we get magnitude in general? If A is equal to xy, then magnitude of A is written as, now we use these symbols in math. When you find double bars, we are meaning find the magnitude, which we shall end with square root of this. Did you know where the square root came from? Because here you have it as what? S squared
Plus B squared.
this vector, not so?
Yes.
Squared is equal to 3 what? Squared. How do I remove a square? I take square root to the other what? Side. Clear? Now, simply, we say magnitude of A will be the square root of X value and Y what? Value. That means magnitude of that will be square root of 9 plus 25 square root of 25, not so? Which is 5 units. Now, in general, every magnitude is got here, not so?
Yes.
Yeah, that's right, that's correct. Oh, now we go into examples. Now, that's very, very correct. Now, given A 3 negative to B 7 7 1, find part A vector AB, part B AB. Is that meaningful to you? Help us. Let me handle this and you handle the rest, not so? That's my example. That means I first have to create what I call OA, not so?
Yes.
Which is 3, 2, and OB, which is 7, 1. Then we go and find what?
AB.
AB. AB is equal to
OB.
OB minus OA, which is 7, 1 minus negative 2, giving us 4, 3. 7 minus 3, 1 minus, I think maybe people want that one shown. 1 minus minus, that gives us 4, 3. That fine? Then how do I get magnitude of AB? The square root of 4 squared plus 3 squared. That is square root of 16 plus 9, which is square root of 25, giving us 5 units. I'm giving you now numbers. You want people to try in only a few minutes. Then you got ratios in vectors. Grace, you feel good?
Yes.
We move not so. Number 2. Number 2. Yeah. That's given. Vector P is 4, 4. And vector Q that's right away negative 4. negative 4. You use this as smaller Q, don't use a capital Q. And that one vector, that gives us negative 8. Find magnitude of P minus Q. Then also magnitude of Q minus P. Could I have people cutting those numbers? Anybody coming, you cut all, and we move on to ratios in vectors. 1 minute per number. Time is on our bad side. I should have who is coming. Mira, you coming? Yes, Mira. You handle it from here, but you handle part A up to here, then the other two.
We are going to find P equals to, then equals to, against the PQ equals to OP equals to OQ minus OP equals to negative 4, negative 8 minus 4, negative 4 minus 4 by negative 8 minus 4 equals negative 4 minus 4. Then
Okay, we are giving out opportunity for one. That means I'll need 3 people. That's all.
is it 12?
Next person. Thank you, Mira. Class, are you in agreement? Come for part B and part B. Who is coming for part B? Hurry up, hurry up.
Okay, finding the magnitude of the vector of P minus the vector of Q. So we have to first find P minus Q. So P is 4 minus Q, which stands for negative 4, negative 8. So you subtract the upper one.
No, wait. Are you saying Miller's work has an error?
No, but okay. So can I continue?
Please continue. Please.
Then 4 minus negative 8. Negative 4 minus negative 4.
Say it again.
Negative 4 minus, 4 minus negative 4. 4
You're trying
minus
to speak new math.
4 minus negative 4.
8.
Then 4 minus negative 8.
12. Okay.
So since we have already found p minus q, so we shall find the magnitude of the vector of q and that of p. So it will be the magnitude of p minus q and the magnitude of p. Okay, p minus q is 8, 12. So we are finding the magnitude where you'll have to use the square root, 8 squared plus 12 squared. So
64 squared plus 144. That is 208.
So what is the square root of 208?
Now, if the answer is not exact,
It is
you compute it and round it off and specify in brackets what did you round it to, at least some decimal places. 1 or 2 decimal places is enough.
14.422.
That is 3 decimal.
Just remove 1.
Then specify to the one who will mark that I rounded it to. Yeah, thank you very much. That means here you tell us that the nearest what? Whole number. But you can leave it at this stage. I hope the other one can be done.
Yeah.
We go to ratios in vectors. Merely you don't, these are smaller letters, therefore they cannot be positioning vectors. That's all. That means this one, oh, you use the capital, that's good. OP would work, yes, you have, but then when you say OP, you don't write it as a coordinate, it becomes 4 up and 4 down. This is now, yes.
On this number here, I worked it out in a different way, and I really.
You have doubted the question. Okay, ratios in vectors. Ratios in vectors. Now we see that a vector, we can divide a vector. Like you can move a distance of 20 kilometers, then we said that in which time did you move 10? That means we can divide a vector in a certain ratio. When you divide a vector, you create 2 vectors. That very clear? When you divide a vector, you create 2 vectors. Consider vector AB shown by the line below. That if you have AB here, then you happen to create another point on it called the point C in the ratio. If C divides AB in the ratio of M to N, can we develop expressions for AC? Because our two vectors created here, there is AC and CA. That means I have a short vector here and another vector here, not so. And I have a whole vector here. Now, it's like if people share 5 or 10 oranges in the ratio of 2 to 5, in the ratio of 2 to 3. If A and B share 10 oranges in the ratio of 2 to 3, what will A get? Yes. How did you achieve that?
You first get the total ratio, which is 5.
Mm.
Then it will be that of A, the ratio of A, which is 2. So it will be 2 out of 5.
Out of the total? Okay, now express for me this AC vector is ratios in terms of M to N, not so? Now that means AC is M over the total ratio times the whole vector called what? Now you must understand that each one will be a portion of the whole of a vector. Is that fine?
Yes.
CB will be N out of the total times also the entire vector called AB. Discussion question is here. Given coordinates of points P and Q as P for 2 and Q that's 5 for trying to be that is 13 5 find A. Let us prove that M is a point on PQ, on line PQ such that it divides the line PQ in the ratio of 1 to 2. Find A, PQ vector. Now, you see, when you have a line, if you write a line can be written as a vector later, not so? But this is a line. Now, vector PM coordinates of M. Yeah. Allow me to take it over under your guidance, not so? Yeah, that means you will guide me as I discuss it over, not so? Now let us discuss it, and we go to translations because now I will have finished vectors. Yeah, are you set?
Yes.
Now, coordinates of points P and Q are these P and this, not so?
Yes.
That means I have to first develop what?
PQ, O,
OP
and
is what? 40,
yes.
not so?
Yes.
Then OQ,
It's 13.5.
13.5, not so?
Yes, sir.
So, how do I get PQ?
OQ
OQ
minus OP.
minus OP. You believe that?
Yes.
Which is
13.5
13.5
minus
42 gives us
9.3.
9.3. Not so?
Yes.
Now, the next one is find P.
M.
Listen, the question said, M is a point on PQ such that it divides the line in the ratio of 1 to 2. That means I have a line called what? PQ. But since I'm talking about vectors, let me not leave that out. But there is a point which divides it in the ratio of 1 to 2. Which portion is big? M to Q is big, in the ratio of 1 to 2. Okay. The question wants?
PM.
How will I achieve that?
So it will be the ratio of PM, which is 1 out of
2? 1 out of 2 or 3?
Out of 3, yes.
The total ratio is 3.
Yes.
That means the portion times who?
Times PQ.
The entire vector, not so?
Yes.
Yes, that's a third times
9.
3. And a third will multiply everybody. Is that correct?
Yes.
Giving us
3, 1.
3, 1, not so. That's called PM.
Yes.
Now, part C.
Coordinates of M.
Who can guide us? That means I have to first find who.
I think MQ.
Because M is OM in vector form.
Yes.
Not so? Therefore, I have to look for
M.
OM. How? We can pick from any of these concepts that we have something again in it. Not so? What is the expression for PM in displacement vector form? PM is AQ handled PQ. Therefore, what is PM?
OP.
Are you sure?
OM minus OP.
That means I can solve for M. When I've got M, I've got the coordinates. That very, very well.
Yeah.
Add the OP on both what? Grace, why were you running? Was the brain about to get berserk?
No.
OM is PM. What is PM?
31.
31. Then I'm adding OP, which is?
42.
Yes, 42. That gives me
73.
Now in coordinate form, coordinates now will be 73. Yeah. That's wonderful. To the teacher is very, very wonderful also. Now the next discussion is on translations. That means I hope you've captured this work very, very well.
Yes.
Now next discussion, we are discussing what? Translations. Now I want to ask you, did we talk about reflection one time?
Yes.
That means subtopic 2 is called translation. Now why is translation coming in here is that it is going to call in the knowledge of vectors. Now, did you recall that we talked about reflection one time?
Yes.
Now, that reflection was, it developed for us a new figure out of the original figure, and the new figure was called the image. Do you recall that?
Yes.
It was called
The
the image. Now, developing a new shape out of an old shape is called transformation. It means for you, when you grow, you transform into. Do you believe that you will grow old?
Yes.
Some of you don't believe it. Now, that means you'll be transformed into a new what? A new somebody. Now, transformation is what we dealt with, the first form of reflection. But reflection created a figure which was the same as the original figure. I hope people recalled that term called congruency. A similar figure exactly the same in size, and all angles are the same. And remember that we called that reflection the figure formed. It was looking the shape after reflection in a mirror line was opposite to the other, and that type of congruence was called opposite congruence. Now, that was in senior 1. But in senior 2, we are introducing another form of transformation called translation. And in senior 3, we shall add in more transformations. We picked one in senior 1, reflection. Here it is, translation. Senior 3, rotation. And enlargement, they will come later there. Now, reflection created the opposite congruence, but translation, as we are going to see, what is to translate? What is to translate? Like in English, we say translate from Luganda to English. You are speaking the same language, but you are speaking the same words, but in different languages. So, now, I want us to notice something here. Are we right there?
Yes.
Now, assuming you are seated as like as you are seated, let me take this example. We are now discussing translation. One person is another person is another person is another person is there, and we happen to move this table with you, with your chairs. We move it, we don't change the direction, but we simply ride it. We ride the table from one point to another. That means the table will be in another position here. Not so?
Yes.
With the chairs, with the people, and with the chairs in another position. But this person, number 1, number 2, number 3, number 4, that means the series of number 1, number 2, number 3, number 4. You have not changed any form to look to the other. Number 1 is still in the front, number 2, they are still in the same far, because we just moved from here to here. Now, this is what we call translating. It is to move from one point to another, but every point moves in the same direction, the same distance. That if this one has moved up to here, if this is 4 centimeters, then this also will be how many? 3 has moved 4 in the same direction, 4 has moved one has moved. Now, that is called a translation, the movement of a figure from one place to another, the same distance, in the same direction. The movement of the figure from one place to another, whereby its points move the same distance in the same direction. Yeah. Now, I want you to now to notice here. Now we are going to representation of a translation. How do we represent a translation? Now look here. Now, since I told you that our graphical work is done in a Cartesian plane, in which there is movement in the x direction horizontally and in the y direction vertically. So a translation is represented by, can somebody guess?
Images.
Sure. Do you agree with me?
Column vector.
Because you are going to move x and y. That's great. X is movement along x-axis, left to right, or right to what? To left. Clear? Then y is movement along y what? Axis, up to down, or down to up. Clear? So now that means I want to give you some graphical work and you translate. Do you have graph papers?
Yes.
You have graph papers? Okay. To translate is to move horizontally first, followed by vertically. Given the coordinates of triangle ABC as A11, B 13, and C 33. Are you set with your graph work? You're ready with your graph work? Okay. Find the image. Find the image of A, B, C. Find the image A prime, B prime of ABC under the translation A T equals 2, negative 2, and B, T, translation is T1, T2 is to T1. Now, we illustrate this and for you plot on actual graph. You're ready? You're set, not so? Yeah. Mira, give us that long ruler. So, are you clear as the saying goes? What is to be clear? To be sober. Are you sober?
Yes.
Okay, now go to your graph paper. There are lines in your graph paper, not so? I'll not take time to draw those lines, but make sure you draw them.
Yes.
That's 1, 2, 3, 4, 5, 6. Just use one unit for one centimeter for 1 unit. Negative 1, negative 2, negative 3. Okay. Have you finished plotting? Finish plotting as we plot, not so? That's 1, 1. Then B is what? Is 1, 3 together. Then C is what? 3. Join. That means get a ruler. That is up we are the same speed, not so? Yeah, now I want to translate. Translate. Okay. Now the first translation 2 is a positive, not so? How many steps are these? 2 steps, x direction, positive. We move each point. I hope people are at peace with me. Now 2, let me start with this. I'm moving 2 units in the positive direction. Your graph paper has boxes already drawn, they are not so lines.
Yes.
That means this is 1, 2. That means the new coordinate will be A. That's so. No, wait. I must translate it to and what? A. Move. 1, 2. But the next one is negative That's y value. Move down 1, 2. That means this is A prime. Next one, yes, move point 1, point B, 1, 2, but negative 2 steps down, 1, 2, this is B what? Then we go to C, 2 positive, 1, 2, then 1, 2, not so? Hope I'm moved, right?
Yes, it is good.
I try. This is C. It must be the same size with direct congruent. That means it should not face opposite each other. This is now the image after translation of T1 also. Okay, now let us go to translation T2. T2 you have to twice this. Or what will it be? T2 will be 2 into 2 negative 2 gives us negative 4. That means I'll now use the same object but move 4 steps and negative 4 steps. Not so? Start with this. 1, 2, 3, 4. Then 1, 2, 3, 4. 3. This is coordinate. Now we use double prime to differentiate. Now remove another one, point B. That means 1, 2, 3, 4 at 5. 1,
Yes.
2, 3, 4. Okay, then from here go down. 1, 2, 3, and 4. Negative 1.
Yes.
That means B double what? Okay, move C. Will my whiteboard allow me?
No, maybe you have to add 8.
You must go up to 80. But you can move and for you draw. Not so? You will join that and also join point C which is around 8. And you complete.
Is
that 7?
Yes.
That will be C double prime. Now I want you to listen. Now we want to develop a formula for translation, and we soon close this topic. Formula for translation. What have we been doing? What do you observe? Let us talk about this and this in terms of the image, and we compare this object using translation into its image. Not so then we develop a formula. Are we at par together? And we discuss the development of the formula. Now, state the coordinates, because we want the coordinates. What are the coordinates of A prime, B prime? Somebody state them for us.
A prime, it is positive 3, negative 1.
Negative 1.
B prime is positive 3, positive 1.
Positive 1.
C prime is positive 5, positive 1.
Positive 1. Then here, A double prime.
It is positive 5, negative 1.
Positive 5.
Negative 3.
Then,
Positive 5, negative 1.
then,
Positive 7, negative 1.
negative 1. Now I want you to let us look at this. What has happened? How did this one affect this? By which operation does this change it to this. That means translation plus object gives us
Image.
exactly. So now let us leave that. And I give you now, people must be ready to come. We shall close with successive translation. Formula for what? Translation. You said that what have we arrived at? Translation? Plus give us what? The image. That means you can make any the subject. Let me, people are ready to cut now numbers as in closure. Yeah.
Yes.
As in what? As in closure. Will somebody summarize for us what we've gone through since we started? That means I'll call one student, you summarize everything that we talked about. That we talked.
So can you summarize from our Can you summarize the good ones?
No, you have to summarize from here, isn't it?
No. Yes.
I want to give you numbers under here. Just briefly, and you calculate. Now how many are ready to come and cut these numbers in closure? You are ready. That would mean the topic was very, very what? Simple. It's very, very simple. Okay, let me now get you the number. Yeah. Yeah, now you can have this. This. A translation T. A translation T. 5-2. I think for translations, just a column vector only. A translation T 5-2 maps point P -3, -2 onto P prime. Find the coordinates of P prime. Find the coordinates of P prime. Let me see somebody rushing in there, then we give another one here and we close. Yes, rushing very, very fast.
I think since we have the translation, so it will be the translation which is t plus the object that we can take as p. So we shall make it -3, -2. So finding the image, we shall have to add the translation plus the object, which shall be so 5 plus -3, 2. Then 2 plus -2. So meaning the coordinates of p prime shall be +2 and 0.
Yeah. Thank you very, very much. Now, people who have not participated, you have this one also. Number 12 point Q 40. That one is pretty easy for somebody. We pick on another one. A point Q under a translation t equal to -1 is mapped on point Q to -1 find the coordinates of Q. Can second person rush and the last person will close. I think let me put for the last person also. Yeah, as we were adding more examples on translation questions, I request that we finish up and sum up the lesson. Who is going to summarize our lesson for the second topic so that we can close this? Now, I think let us go through. Since you've done many, let me also take over the remaining ones under your guidance. Now, the number 2, we finished number 1 already. A point Q under a translation T is mapped onto the image. That means Q is the object, then Q prime is the image. So, who can remind us that formula? What have we been saying?
Translation plus object is equal to image.
That's good, class. Translation plus object gives us the image. So, the image is given. It means I have the translation as -1 plus our Q is equal to the image, which is this. We agree with that? Yes. Therefore, we take this side. Since we use subtraction, take it the other side. Or rather, we would have modified our formula to say object minus translation. That's good. That means I will have 2 -1 minus -1 -1 giving us that will give us, this is a positive, that means we get 3, 0. That's very good. Now the coordinates of Q will be 3, 0. That's very good. I think we finish up with number 3. Is that fine? Yes. Number 3. Now, even after doing this, we can ask you to put it on a graph paper. Put the object and its image on the graph paper after working out. Now this last question is saying a triangle MNO whose coordinates are M, N, and O is mapped onto the image, clear, by a translation 3T, where T is this. Now if you have several coordinates, we must find the image for each coordinate respectively. So again, the formula applies called translation plus object equals to image. Okay, starting with M prime will be the translation, but we've not found the translation is 3T. That means translation is 3T. First get 3 into -1, 2, giving us -3, 6. That's very good. That's very good. Now I start with the first image will equal to its object, -1, 1 plus the translation which is 3, 6. I hope you'll not complain that I should start with the translation. Addition is, we say it's commutative. You can start with any. That means you'll have -1 plus -3, then 1 plus 6. That gives you 4 with 7. And now the coordinate is -4, 7. That's very good. So you proceed and find for aim. For what? For N. N prime will also be, I think that's what? 20 plus 6. That will give 2 plus -3? -1. 0 plus 6? 6 coordinates? 6. Okay, go to O prime. O prime would be 6 plus -3, 6. That yields 6 plus -3, 3. -1 plus 6, 5 positive. Coordinates will be 3, 5. That's good. That's good. That's good. Yeah, good. That very, very right. See. Now I think we could summarize, not so? Now I hope you are very, very aware of what we've gone through. Who has a summary for us to close the lesson? Mokisa, you want to sum up? No. Okay, we said that the major topic was vectors and translations, and we emphasized, we said it is now categorized into vectors alone and also translations at the second subtopic. Now, under vectors we saw meaning of a vector and examples of vectors. And we say the vector is any quantity with both magnitude and direction. Then we also spoke about a scalar as a number or a quantity with only direction, with only magnitude but no direction. And we say the magnitude can also be called length, size, or modulus. Then we right away talked about representation of a vector, both geometrically and symbolically. Then we proceeded to the types or categories of vectors. And we said there are not only two, position and displacement, but there are others like parallel vectors. You see that? We now operated on vectors, addition and subtraction, and multiplication by a scalar. Then we proceeded now to finding the magnitude of a vector, and finally the ratios in vectors. So that threw us to translations, where we saw the meaning of a translation, representation of a translation using a column vector. See? Then we proceeded now to handling, finding the image using the formulas for the translation plus object is equal to image. I hope that's what we saw. Now I want to thank you, and I request that we meet in topic 3, read about it, which is graphs. Yeah.